Really? When I was growing up, it feels like at least once a year we got a good snow day. You can just do it on the paper here. That's why this looks a lot more than what it is. I just decided to run you kind of the guided notes. I don't usually do that with honors because y'all don't usually need it. But but I do want to run through a couple of these. So the discriminant is just a part of the quadratic formula. So let me write the quadratic formula. Actually, you tell me what's the quadratic formula. Opposite B all over 2A. That's right. That's right. Good job. Good job. Good job. How many of you have, maybe you haven't recorded your song, but you've worked out what you're doing? Yeah. You've already recorded, hadn't you? Good job. Anybody else? No. All right. So the discriminant here is just the part that's under the radical. Okay. So B squared minus 4AC, that is my discriminant. Not the square root part of it, just the B squared minus 4AC. So where's this formula for the discriminant of a quadratic equation? B squared minus 4AC. Just, and here's what it does. So what's under the radical gives me a clue as to what kind of solutions I'm going to have, okay? Because if I take the square root of a regular old number, how many answers do I get? 2, right? Because the square root of 4 is or 2 or negative 2, right? There's 2 answers, right? And that's kind of where this is coming from. So this, I'm going to say, they use D for discriminant, and they say D equals B squared minus 4AC. And you've got this little chart here, right? And it says, if D is greater than 0, meaning it's positive, that's what that means. That very first line means D is positive. The discriminant is positive. Then I get, and you can write the same thing for both of these first 2 lines. I don't really care if it's a perfect square or not. This is still going to happen. So those first 2 lines are together. I don't ever separate them. Excuse me. The number of roots or number of solutions is going to be 2. And the type of roots are going to be real. So if you plug into B squared minus 4AC, you get 2 real solutions every single time. It's positive. Okay. But if you come up and let's say, and I'm going to skip down to the bottom one here. Let's say it's less than 0, which means I'm dealing with what kind of number? Negative. What happens when you get the square root of a negative number? You have to take the I out. I'm in imaginary land, right? So if I get a negative under the square root, if I just plug into this B squared minus 4AC and I get a negative number, I end up with 2 imaginary solutions. Does it make sense? Why? Okay. And the only other situation that can happen, I could be positive, I could be negative, or I could actually be 0. And if I'm 0, if you think about this whole quadratic formula, if that whole radical part is 0, then it's gone. I just end up with this, which would just be 1 answer only. So this is 1 real solution. Yes, yeah. Those first 2 lines are exactly the same. So for example, let's just look at number 3. Negative 4x squared plus 84 equals 10x. And the only thing it says is find the discriminant and describe the solution. So first off is the discriminant, but before I can do discriminant or any type of quadratic formula, I need to make sure I do what? Equal it to 0. That's exactly right. So I'm going to move the 10x over, I think. If you moved everything else, that's okay, because quadratic formula does not matter. Now plug in your b squared minus 4ac and tell me what you get. Bless you. Bless you. Oh, this is a big number. I got 1444. Is that what y'all got? What's that tell me about the solution? Yep. All you have to put is 2 real solutions. And that's like 1444 is not a solution. That is just the discriminant. That's just what sits under the radical. But it tells us how many solutions we're going to have. Does that make sense to everybody? How we just kind of use it to tell what we're going to get? All right. So on to the review as you'll look at the rest of this packet. The hard part, in my opinion, about bringing all this together with quadratics is knowing what to do when. Like if I tell you solve by completing the square, you know what to do. If I tell you solve by factoring, you know what to do. But what if I don't tell you what to do? What if I just say solve? It can be kind of difficult to know, well, what the heck am I supposed to do? Which way do I solve it? And so that's what we're focusing on today, is how to know what we do and when. So here's what I want you to do. I want you to mark the pages that you do. Actually, let's do the first page together. Let's just do this first page together. The back of the first page, let's do that together to decide so you can see how I use what I'm given to determine what I want to do. So I've got 4 equations up top, and then I've got 4 different methods of solving, and it says to use each method only one time, okay? But I've got to decide, well, which one lends itself to what the best. So let's just look at the equations here. Equation 1, equation 2, equation 3. And I'm going to ignore the discriminant part right now and just focus on solving. My first thing I always look for, it's always the very first thing I do when I solve a quadratic is, can I stat map my way out of it? What do I mean by that? That's using square roots. That's where you only see one x. That's always the very first thing that I look for. So in looking at these, do you see one that I could solve that way? Yep, equation B, right? For this one, I'm thinking I could use square roots. In other words, I could go backwards and solve it for x. So if I go down to that square, that's the top right square there, I am going to go ahead and solve that way. So what do I do first? Don't be shy. What do you do first? How you solve that equation? How you get x by itself? Subtract 144, right? Remember, I need to work my way furthest away from x first and then work into x. So I got negative 2x squared equals negative 144. Now what do I do? Divide by negative 2. So I've got x squared equals 72. What now? Can I leave it like that? Why? I can simplify it. I can do this with it, right? What's the biggest perfect square that you can divide 72 by? 9, even bigger than 9 actually. 36 and 2, right? So I could do 36 and 2, which leaves me with 6 root 2. Yep, plus or minus. There's my two real answers, okay? That's right, because that's half your credit, right? That's half your answer. All right, back up to the equations up here. So I've used square roots, that's good. The next thing I always look for is which one could I factor very easily? In other words, if I multiply the first and the last together, can I come up with two things that multiply to give me what's in the middle? 3? Yes, I agree. 21, yeah. Yes, I agree. I agree. I would say that's a good one to factor. In glancing at them, if you're not that quick with it, it's okay. Looking at these, 21 times x is 21x squared, right? I can't think of anything off the top of my head that multiplies to 21 but adds to negative 9. Here, I can't think of anything that multiplies to negative 15 but adds to 6. But here, I can think of something that multiplies to 21 but adds to 22. So I think that's going to be my factor. So I'm going to go to the factor box. Do you see how I'm reasoning through this to determine what method is the best to use? And it's not, remember, quadratic formula will always work, but if I could use another method, it'll make my life a little bit easier. All right, so here, I'm going to multiply the first and the last together to get 21x squared. What multiplies to 21x squared but adds to negative 22? That's right, negative 21 and negative 1. So I'm just going to rewrite that equation. And slash. What do you get? What's the GCF of the first two? 3x. Leaves me with what? X minus 7. Remember that middle sign stays, but it causes that last sign to change. So it doesn't have, I don't have a GCF here, so I'm going to hold the place with a 1, and that leaves me with x minus 7. So now I have x minus 7 times 3x minus 1 equals 0. And I'm not done. Why am I not done yet? That's right. Everybody's got to go to 0. I've got to split them up. So here, x minus 7 equals 0, and 3x minus 1 equals 0. Seven and 1/3. Is everybody okay? All right. I still got two methods left. I saved the hardest two for last. Well, the hardest one and one of the last two. But now I need to determine completing the square as opposed to quadratic formula. So I'm back up to my two that are left, and I'm going, complete the square quadratic formula. I always save quadratic formula for absolutely last. So which one of these two would it be easier to complete the square for, and why? Why? That's exactly right. That's exactly the way I think about it. When you look at this, remember to find a good C, I have to cut the middle in half and square it. If it's not an even number in the middle, boy, I don't want to be dividing that by 2 and squaring it, right? Because I'll be into some nasty fractions. But if it's like this, where I can easily take half of it and square it, it's going to make my life a lot easier. So let's run through these steps on completing the square. This is a good review for us of all these different methods. All right. Go again. That's exactly right. I'm going to move that 15 over because that 15 is a bad C. It's not even a perfect square. It's not even in the running for a good C. So I'm going to move it over, and when I do, I'm going to hold the spot that it was in here so I can put in what is a good C. And then I'm going to do the same thing on the other side because to keep my equation balanced, I need to make sure I do that on both. What is the good C that goes there? What value would make that square dance? 9. Half the middle squared. Y'all remembering all this? We've learned a lot. This unit's big. All right. How does the left side factor? That's right. Equals 24. Now I can go ahead with square roots. Got to split it up. That's exactly right. What's the perfect square you can take out? 4. 4 and 6. So that gives me 2 root 6. I need to make sure I remember the plus or minus in front because that gives me the 2 answers. But I still got that 3 on the left side. What do I do with it? Subtract it. That's exactly right. So my solutions are going to be -3. Plus or minus gives me my 2 solutions there, 2 root 6. That only leaves 1, as it should, because quadratic formula should be the one whenever I can't figure out what else to do. Then I do quadratic formula. Y'all ready? Opposite B. What's opposite B? 9. Plus or minus square root of what? Minus 4 times, times 21. All over 2 times 1. Clean up the radical first before you do anything else. 9 plus or minus the square root of 81 minus 84. Ooh, this is nice. I got a -3 under there. What in the world does that mean? I got to do the I. I got to do the imaginary. So I'll get an I with a square root of 3. By the way, while y'all are copying that, what's the discriminant of that one? If I ask you for the value of the discriminant. Negative what? 3. The discriminant is -3 because it's just what is under the radical. That's it. All right, let me tell you what I want you to do because I want you to work together on this for sure. What time is it? An hour. Okay, I want you to do these 12 on this review page, okay? But they should go quick because most of them they tell you what to do. But then I want you to flip over and I only want you to do the back of this page. All right, let me go back to the beginning so you know. The page that says review. Let's go mark out 2, 4, and 6 on that page. Okay. Let me be marking them. Flip over to the back of that page. And mark out 8. And then mark out 9 through 12. So mark out 8 through 12. Because here's what we're going to do. Mark out the whole front of the next page. But I want you to do the whole back of that page. Homework 8, mark out the front, only do the back. But then the quiz, I want you to do all of the quiz. I think that's doable. No, you don't have to do anything with those first 2 pages we did together. If you want to rip those off, put them in your notebook so they don't mess you up. Yes, we're not trying to say. I think that's doable. Yes, absolutely. Yeah. And 9:35. I have to do it. You can't be leaving those things up there. Forgot about it.